Today we're going to talk about G7. How does mass affect force and acceleration? So force is affected by two variables. Force is affected by mass, and force is affected by acceleration. This is also Newton's second law of motion. In case you're curious, force is equal to mass times acceleration. Now, if acceleration is constant, and this is primarily what your questions will be on stage 1, more mass will basically mean that there needs to be more force to keep it at that acceleration. Consequently, if the object is less massive, you will need less force to maintain that acceleration. If all objects maintain the same acceleration, then the more massive objects will need more force to maintain that speed. So just as a quick example, which objects needs more force to move? So you'll notice that there's a small car here, and then there's a much larger car here. So the less massive car will need less force to maintain its acceleration, while the more massive object will require more force in order to maintain its acceleration. And same thing here, this small car versus the big truck in the background. Once again, a less massive object requires less force in order to keep its acceleration. The bigger object or the car will need more force because it's more massive in order to maintain its acceleration. If force is constant, and this is stage 2, so more mass will then mean less acceleration, and less mass will then mean more acceleration. So if all objects exerted the same amount of force, then the more massive objects result in lower acceleration or lower change in speed. So in this example, if this object is less massive and it had the same amount of force applied to it, it'll move faster or accelerate faster compared to this object if they both had the same amount of force applied. Because this one's less massive, so it needs less force to hit that acceleration, whereas this one will need more force. Once again, which one will accelerate more easily? The less massive object will accelerate faster, while the more massive object will accelerate slower. And once again, this is assuming that they both experience the same amount of force. Now on to some practice problems. So, Kelsey's bicycle has the same acceleration at the start of each of her deliveries. Order the newspapers to show the size of the force she applies to the bicycle when starting each delivery. So, once again, acceleration is the same. If the acceleration is constant, the more massive the object is, the more force you need to maintain that acceleration. So in this example, you will need to put the more massive objects with more force and the less massive objects with less force. So weekends at the bottom, followed by midweek, followed by special edition, then beginning of the week, and lastly, holiday. Once again, size of the force, the more massive it is, the more force you need to move it at that acceleration. So gray would be the smallest, so that's the smallest force, followed by speckled, then white, then brown, and then black would require the most force because it's the most massive. And then right here, same idea, size of the force. So in this one, the least massive object would be Margate, I believe. So that'll be first, followed then by Premier, then it would go to Gardenia, then it would be Adelaide, and then Brightstar as the most massive. Alright, stage 2. So in this instance, the acceleration is what we're trying to figure out. The force is constant. So be aware, guys, that if the force is constant, the more massive the object is, the less its acceleration it has. The less massive the object is, the more acceleration it will have, assuming that force was the same. Okay? So here, the lightest one is silver. So silver would have the most acceleration, followed by green, then gold, then red, and then blue. Once again, more massive objects, less acceleration. So, and then vice versa. So let's go with large acceleration will be smallest, so Preston would be first, followed then by Danny, followed then by Kevin, then it'd be Jane, and then Rosa would be at. So in stage 3, they're going to ask questions on the size of the force and also ask questions on the size of the acceleration, which is what you've done in stage 1 and stage 2. The only difference is that this time you have to calculate the specific amount of mass for each object. So it says each truck has the same acceleration as it begins moving. Order the size of the force on each truck as it starts to move. So once again, the greater the mass, the greater the amount of force you need to move that object. Now the tricky part is this. There are 2 boxes of books, and each box of books has a mass of 40 kilograms. So what you'd have to do is you have to do 40 times 2, and then you'll get a total of 80 kilograms for the boxes of books. For the second one, you have a carpet that's 30 kilograms each, and you have 5 carpets total. So 30 times 5 is equal to 150 kilograms for the carpets. Next one, we have 20 pieces of furniture, and each piece of furniture is 120 kilograms. So 120 times 20 is a very big number. 12 times 2 is 24, so I believe that's 2,400 kilograms of pieces of furniture. And then 10 tires times the mass of each tire is 10, so 10 times 10 is equal to 100 kilograms for the tires. So in terms of ordering, it would be the boxes of books first, followed by the tires, then the carpets, and then the furniture would be last. Alright, so books first, then tires, then the carpets, and then furniture is the largest one. Next one here, size of the acceleration. So this time, once again, the greater the mass, the lower the acceleration for that object, assuming that the force is the same. So for this one, we have 4 bundles of wheat times 20 bundles total, so you're going to get a total of 80 kilograms for the bundles of wheat. For the next one, large stone, you got 6 kilograms for each one, multiplied by 2 large stones is equal to 12 kilograms for the large stones. Next one, you got 10 sacks of compost, and you got 20 for each one. So 20 times 10 is equal to 200 kilograms for the sacks of compost. And then last but not least, there's 8 kilograms for each wooden post, and there's 5 of them total, so that's going to be a total of 40 kilograms for the wooden posts. So once again, the larger the amount of mass, the slower it will go in terms of acceleration. So in this case, the smallest one is the 12. So 12 kilograms of, so the stones, then the posts, then the wheat. So stones, then the posts, then the wheat, and then the compost at the end. Okay, and I'll do just one more. So size of acceleration. So once again, the larger the mass, the lower it will accelerate. So for this one, we got 500 boxes of chicken wings multiplied by 5 is 2,500 kilograms of the boxes of wings. Next one, you got 400, oh, it's just 400 grams now. Oops. So 400 grams multiplied by 2 pasta dishes is equal to 800 grams for the pasta dishes. Next one is going to be 900 multiplied by 10 is equal to 9,000 pizzas for the grams or the mass of pizzas. And last but not least, you got 200 for each salad, and there's 20 salads, so that's going to get you a total of 4,000 grams of salads. So in this instance, your pasta dish is the smallest, followed by the boxes of wings, and I'm going to put this in the correct order so I don't get mixed up. And then you got the pizzas at the end. So the largest acceleration would be dishes, then wings, then salads and pizzas. Dishes, wings, salads, pizzas. All right, and there you have it. Hopefully you guys get the general idea of how to do these questions here.